This is 99% Invisible. I'm Roman Mars. This is part 2 of the 2020-2021 mini-stories episodes where I interview the staff and our collaborators about their favorite little stories from the built world that don't quite fill out an entire episode for whatever reason, but they are cool 99PI stories nonetheless. We have space pens, sea sheep, that'll make more sense here in a second, circular design, and a seasonal national forest populated by old Christmas trees. Stay with us. So I'm talking with Emmett Fitzgerald. What is the mini story you have for us?
All right, so I came across this story while I was reporting our peat bogs episode from a couple weeks back. It's also a Scottish climate change story in a certain way.
Climate change stories, Scottish or otherwise, is definitely your beat.
But we'll get to the climate change part in a little bit. But first, I want to introduce you to Sean Tarrant. She is a woman who lives on a tiny island in Scotland called North Ronaldsay,
which is the northernmost island on Orkney, which is just north of Scotland. It's a really small island. It's about 5 miles long and 1 mile wide. And at the moment, it's got 62 residents.
Wow.
Yeah.
Of which you are one.
Yeah. So I think when we arrived, it was maybe mid-50s. So it's gone up a little bit since we arrived. There's been 2 more families arrived since we moved here, which has been great.
The island actually had more people all the way back in the 1700s. The main industry at the time was seaweed. It's really stormy up there, and so there's kelp, like lots of kelp, just constantly washing up on the beaches. And the people on North Ronaldsay would gather it up, and it was used to make iodine or sometimes burned to make potash, which was a common industrial chemical at the time.
So they had, a really booming industry in the 1700s, and they had about 500 people living here at the time. But unfortunately, that kelp industry collapsed sort of 50 or so years later.
And so the islanders needed a new industry, a new way to support themselves. And they decided to really focus in on agriculture and cattle specifically. But the issue with that was that it's a really tiny island and they had, limited space for cows.
Right.
And particularly they decided that there wasn't enough grass to share between the cows and the sheep. And so in 1832, they came together and hatched this plan. They were going to build a stone wall all the way around the island in order to separate the sheep from the cattle. And, the idea was that they would save all that good grass in the middle of the island for the cows.
Where are the sheep supposed to go then?
Well, that's where the story gets interesting. So the stone wall, or the dike, as they call it, basically pushed all of the island's sheep onto the shoreline where they were supposed to survive by eating all that seaweed.
So ever since 1832, the sheep have been kept just on the beaches where they learnt to survive by eating the seaweed and, kind of like sheltering against this 6-foot-high dike, which goes all the way around the island.
And so this worked? Like sheep were able to survive on the beach eating kelp?
Yeah, so over the years, centuries, really, the sheep basically learned how to eat kelp and survive entirely off kelp. And now, if you visit North Ronaldsay, you'll see hundreds of sheep wading into the waters around the shoreline and just like munching on kelp.
So they tend to wait for the low tides. They wait for the water to go out, which kind of reveals all of the fresh seaweed, and then they'll all flock down right next to the water, if it's not too stormy, and just kind of like start feasting. And you'll see them, tackling these huge like fronds of kelp and just kind of like munching it down straight away. And you'll see some animals kind of like swimming out to little rocks. So they're kind of like wading out to get the freshest and the best seaweed that they possibly can.
It seems so lovely and whimsical, little floating sheep out on your shoreline. It's even more delightful than I imagined.
Yeah, totally. Sean says they don't look like the kind of pristine white Scottish sheep that you imagine. She says they sort of look more like a kind of like grizzled old like seafaring sailor sheep.
Yeah, some of the rams especially look pretty battered by the weather, I guess.
They've got like peg legs and eye patches.
Exactly.
So was it hard for the sheep to adapt to their marine lifestyle? I mean, like, how do you make amphibious sheep?
Yeah, I asked Sean about this.
Mhm.
The archaeological evidence suggests that the sheep were actually eating some seaweed before this. There's so much seaweed on the shoreline, and that's probably, what gave the islanders in 1832 the idea that this might work.
Mhm.
But, after the wall went up, they had to adjust to a diet that was entirely seaweed, which is actually like a pretty different food than grass on a chemical level.
Seaweed is very low in copper, which is something that we all need in quite small doses, but you still need a little bit of copper in your diet to function. And what they've evolved to become is very sensitive to the copper in their diet, so they can extract, every sort of single milligram of copper that's available in the seaweed. So unfortunately, when they go on grass, they can be sort of oversensitive to the copper in grass, and potentially get copper poisoning. They're the most copper sensitive animals that we know of in the whole world. So they've done an amazing job at sort of adapting to their environment in order to get what they need from it.
I mean, that is so fascinating. The idea that they could poison themselves with copper because they are so adept at taking in whatever copper is available is so cool.
Yeah. Yeah, and it's
kind of stunning.
What's amazing to me is it's all because of this wall. Like they've physically changed because of this piece of human infrastructure. It's like changed their biology.
That's wild. So they can't climb the wall? I mean, like it's lasted this whole time and like never had a sheep go free.
No, I think that occasionally, they know they get copper poisoning because occasionally they will sort of like get through a hole or like, and actually Sean said that there's been stories of sheep climbing onto each other's backs to get over the wall. But the vast majority of the sheep have maintained their shoreline lifestyle over 2 centuries. Because this wall is there, and the way the system works is the sheep are owned by individual people on the island, individual farmers, but they're managed collectively, and so that includes the wall. The wall's maintenance is sort of a collective project by all of the sheep owners on the island, and so for generations the sheep owners sort of work together to keep this thing standing. But keep in mind, like, this wall is 12 miles long. It's actually one of the longest dry stone walls in the world.
Wow. You mean like it doesn't have mortar, like it just is like stacks of stones.
Right.
That makes it even more amazing that it's been so robust for so long.
Well, yes and no. Like it's kind of constantly crumbling and falling down in places, and so it's been this like years long project to maintain it, and that's been the job of the islanders. But over the years, as the human population of North Ronaldsay has diminished, it's been harder and harder, and so like at times they've built some sort of fencing to plug some of the gaps. But it's been a problem, and so last year they came together and they decided, like, let's hire some young fit whippersnapper to go to like whose like job it would be to just like deal with this problem and fix the wall and make that their full-time job. And the person who answered the job posting was Sean.
It just sounded, really, idyllic. I'd spent a lot of time on different islands in remote places and just wanted to find a job that would have me sort of outdoors for most of the time.
That's amazing. I totally see why she did that. Like, that sounds so ideal to me too.
She spends most of her time just like walking around the island and making sure that the sheep are on the right side of the wall, and then looking for gaps and places where the stone wall needs to be repaired. And then it's basically on her. She rebuilds those spots by hand using rocks that are there on the beach, or the rocks that were originally part of the wall that fell down. But again, there's no mortar to keep everything together. You've got to pick exactly the right rock for the right place. It reminds me of stacking wood. I
think it's like a giant jigsaw puzzle. But on the whole, it's really therapeutic, I think, just to spend some time and be working with your hands.
Although she did admit that, the task is enormous, and at times it can feel totally Sisyphean, like you're just sort of going around the island. And as soon as you fix something, there's something else that needs to be fixed.
Sure.
The plan before the pandemic was actually for Sean to sort of, in addition to working on the wall, to coordinate a volunteer program so that, you'd get more people to come and visit North Ronaldsay, and they would help her build the wall. But that all has gotten put on hold with COVID. So it's just her, and she just keeps at it, little bit every day at a time.
I mean, it feels like a folk tale or like some, maudlin short story, although she doesn't sound maudlin, but it has the qualities of that.
Yeah, totally. Yeah, exactly. I think that's a little bit of what drew me to it, is just sort of imagining her working to preserve this rare breed of sheep, like one stone at a time.
So that's so cool. So at the top, you mentioned that this is a climate change story. So how is this a climate change story?
As you probably know, livestock produce a huge amount of greenhouse gases.
Yeah, of course.
Through their farts and their burps, which give off methane, mostly other gases too, but mostly methane. And cows are the worst offenders here, but livestock as a whole are by some estimates are responsible for about 15% of all greenhouse gas emissions globally. So it's a really massive thing that we need to theoretically deal with if we're going to deal with climate change.
Mm-hmm, mm-hmm.
But recently there's been this kind of interesting development, which is that a few different scientists from around the world have studied and figured out that if you feed cows seaweed, you can actually really dramatically reduce their methane emissions.
Wow. Okay. That's so cool. I can see how that ties in now.
And so you're seeing a ton of research into this right now, into seaweeds and cattle and which types of seaweeds reduce methane and how much you would need to add to their food. So you've got, the background, you've got all this research going on that's mostly focused on cows, but sheep also produce methane. And so, the thing that I guess in terms of our story, the cool thing is, you've got these sheep on North Ronaldsay and theoretically you wouldn't need to add anything to their diet.
You don't have to do anything. They're pre-made.
Nothing but seaweed.
Yeah. That's so funny.
There's a lot we don't know, but the thinking is that maybe these sheep, have important information, things that people can learn about how sheep and cows and their stomachs break down seaweed and what's going on in kind of a chemical level.
I'm sure it would be beneficial to look at the sheep that are here that are actually surviving on seaweed, the whole time. Potentially they've got, these unique enzymes and gut bacteria that can be really useful to science. So it just goes to show, I guess, that it's really important to sort of save all these different rare breeds and not to just have one breed of super sheep available.
So are scientists like flocking to North Ronaldsay to study the sheep and save us from the agricultural exactly to study the sheep and just like save us from being inundated with methane from sheep farts?
I think that some scientists have begun to look at this, but again, like that's kind of been put on pause because of the pandemic. But yeah, I think that would be a really fascinating thing to look at. And like, what is the climate contribution of the North Ronaldsay sheep population? Maybe it's nothing. Maybe it isn't. Maybe they still have. Maybe they still emit a lot of methane. But I think it's worth looking at. And so when Sean first got there, it was really more about, just sort of the cultural heritage of preserving these sheep. But now there's sort of like this scientific reason too, that like maybe these sheep have important, information inside of them that could be beneficial for science, really.
Yeah, that's amazing. That makes it even more of a folk tale. It just goes to show how, just like Sean said, like the importance of, maintaining rare breeds and variety and culture, because you never know what's going to save us, Yeah. Like, it's really stunning. Well, that's such a good story. Oh, I love it. I'm going to think about this a lot. about being the wall builder on the island of North Ronaldsay. I now have a new dream job. That's right up there.
Yeah, well, I think Sean is serving a 3-year term. So when it's over, maybe,
that's right. I'm going to get my application ready.
Yeah. Or, again, I know I've suggested you going to Scotland to see the peat bogs. Like on your way up from the peat bogs, you could make a stop in and be a volunteer building the wall.
I'm so on board with this. Like, you think I might be joking just for the sake of doing it on the radio, but like, I am so on board for this.
All right. Well, I'll let Sean know to expect your service.
I'm so there. Thank you so much, Emmett.
Thank you.
So after we published our book, The 99% Invisible City, Kurt Kolstad and I went on Reddit to answer some questions from fans, and one of them asked us if we'd be interested in covering left-handedness. So Kurt wrote an article about the challenges of being a lefty in a world mainly designed for righties, but it also reminded him of another story that he's been wanting to tell, and it's about an object designed not just for left-handed or right-handed people, but for anyone, anywhere, and I do mean anywhere.
Yes, anywhere. And this idea has been sitting on my shelf for a while. And it starts with this anecdote that I've heard since I was a kid. It's kind of like an urban legend or a joke.
Mm-hmm.
And it goes like this. During the space race, NASA supposedly spent millions of dollars developing a space pen, while the Soviets just used a pencil.
Right, right. I've heard it too. I mean, it's pretty funny, but it totally sounds bogus.
And it really is. The reality is that for a long time, both the US and Soviet space programs struggled to figure out ways to write in space. And they had tried out things like regular pencils and mechanical pencils, but fragments of graphite floating around could be really dangerous. Even grease pencils could flake and break apart. And yeah, it was a really big mess.
That was part of the story that's the part that never rang true to me, because if you've ever sharpened a pencil, little things float around and like they're on the ground, they're all over it. And you can imagine that just like working their way into any type of electronics or something. Like there's a reason why you wouldn't have a pencil in space.
Absolutely. They have to keep track of everything up there. You can't have little particulates that could like clog the air filters or like mess with the electronics. I mean, this is like life threatening.
Right, right. And
so that's where this Fisher space pen actually does come in.
Okay, so the sort of apocryphal nature of the two different styles, and that's, you know, like, and show the wastefulness, you know, may be a little bit heightened and a little bogus, but there was really a space pen that got made.
Yeah, so like any good urban legend, there are bits of truth to this. Like, it really did cost millions of dollars to develop, but it wasn't made by NASA. It was made for NASA and every other space agency that wanted one. And the guy who made it was named Paul Fisher, and he just took it upon himself to figure out how to make a pen for space that would work in any conditions, like extreme temperatures, zero gravity. And he did all this R&D and he solved it.
Huh. And then did he just license it to all these space agencies, like for millions of dollars?
You know, I would have thought so, and I might have done that if I were him. But no, he put in all this research and they just sold them basically at cost or at, you know, retail prices to any space agency that's interested. And it turned out these were really important for these space agencies because keeping manual records in space of readouts from computers and everything else is really important. And it just kind of blows my mind that all of these literal rocket scientists, with their attention to detail and safety and everything else, hadn't been able to crack this thing. But this private businessman just said, I'm going to do it. I'm going to solve this, and I'm going to make a pen that writes in space.
Huh. And so how did he do it? How do these magical pens actually work?
The key basically is nitrogen pressurized, hermetically sealed ink cartridges. So if you think about it, like most pens use gravity to drain ink down onto a page, but these pens actively push the ink out. And while they were made for use in space, they proved pretty popular on Earth too. And they proved popular with right-handed people, but especially left-handed people too.
Okay, so tell me how a sort of anti-gravity pen can help a left-handed person in particular. Like walk me through the mechanics of that.
Right. So let's just imagine a ballpoint pen for comparison. Now, as a right-handed person, you hold it in your hand and you kind of drag it across the page. And that works fine, and gravity drains the ink out. But if you put it in your left hand and you're writing from left to right, you're basically working against the mechanism, sort of jamming the pen into the page, and the ink just doesn't flow properly.
So yeah, because with a right hand, you're dragging it across the page, and so you're pulling that ball with the ink on it. But with the left hand, you're pushing it into the page, and therefore the ink isn't flowing properly and getting it out there. That makes some sense. So with the space pen, it really doesn't matter how you hold it because it has the nitrogen pressurized ink, and so it just writes no matter what.
Exactly. It has no directionality at all. You could be a righty, you could be a lefty, you could be sitting back in your chair and holding a pad up in the air and writing upside down if you want to. So it was made for people who are literally heading out to explore the universe, but it turns out to be a pretty neat universal design on Earth, too.
Huh. It's almost like we should revise that apocryphal story and say every space agency in the world wanted a space pen, and no agency actually did it, government agency did it, but a scrappy entrepreneur figured it out and sold it to them. That apocryphal story is used as an example of the wastefulness of a government-based bureaucracy, but it turns out that the true story is extremely American.
Yeah. To this day, Fisher sells all of these different space pens and ink cartridges, and I even have one myself because it's nice to have, right? It's nice to have a pen where you don't have to worry about it like drying out on you mid-sentence. You could just kind of throw it in your backpack and it goes anywhere with you. So I think it's great. Yeah, it's a very American entrepreneurial story. And I think personally that this is as good as the original story. I mean, the lesson of the original story, keep it simple, government bureaucracy, that's a lesson we can learn in a lot of places. But this is just a lesson of tenacity and figuring out what turned out to be a relatively simple engineering solution and then applying it and selling it to the world.
I mean, this is like more of a true story of design, of iteration and perfection, and then being rewarded for it.
Exactly.
So if you're interested in Kurt's longer article about left-handed design, it's titled Left Behind, appropriately, and you can find it embedded in this episode's web companion at 99pi.org. If you celebrate Christmas in the traditional Western ways, probably within the past couple of weeks, you had to contend with what to do with your old Christmas tree. Back when I lived in San Francisco, I remember that people would collect other people's trees from the curb before the green waste truck could pick them up and drag them all to Ocean Beach to make the biggest bonfire I've ever seen. The flames were like 50 feet tall. It actually scared me. But if you live in Nome, Alaska, your old Christmas tree serves a noble purpose. It will become part of the seasonal Nome National Forest. Each year, old Christmas trees are arranged on the Bering Sea ice in front of Nome into a temporary display, which they accent with wooden stand-ups of cartoon characters and a sign that reads appropriately, Nome National Forest. You can see pictures online. It is delightful and silly. And then, when the ice begins to melt, the caretakers collect the wooden cutouts and the sign, and eventually, the ice breaks up and carries the old Christmas trees out to sea. We have more minis after this. For this mini story, we're going to do something a little bit different. Every once in a while, with the help of the Autodesk Foundation, we like to cover impact design, which is design that's focused on making the world a better place. And to that end, I'm talking with Zoe Besfalco, who is the impact and design lead at the Autodesk Foundation, about some innovative design approaches to environmental sustainability, to what's known as circularity. Hey, Zoe.
Hi.
So you've come on to talk to me a little bit about circularity and different companies that are thinking of circularity in new ways. So first of all, let's just start with, what is the definition of circularity?
The simple definition of circularity is to use a product at its highest value for as long as possible. And that can mean the product itself, its material, or the component it's made of. And for this, you need to build circular system or closed loop system that basically minimize the use of resources input and the creation of waste.
And this is opposed to a linear system in which you get a bunch of materials, you manufacture it into something, and then eventually you just throw that thing away. It's a straight line to the garbage dump.
Yeah. So closed loop systems like reusing, sharing, repairing, refurbishing, remanufacturing, recycling are regenerative by design.
I think most people, when they probably hear the word circularity, they probably think of the word recycling. What is the difference between the two?
So, I mean, recycling is one piece of the puzzle for circularity, and it's a great promise, but it's not working alone, you know? Otherwise, we wouldn't be sending so much into landfill. Actually, today we recycle, 9% of our plastic. I think overall on our waste, it's about 30%.
9% of plastic. Wow.
The difference is, I think, circularity is that it goes way beyond recycling. It's thinking about other models like reusing, like remanufacturing, like refurbishing. It's also based into not only the material that the products are made of, meaning that, we're recycling cans into cans, paper into paper, and so forth, but it's really thinking about the product, their design, and the way they are manufactured. It's also thinking about the business model in which these products are being built, and then the infrastructure that support this product lifecycle, meaning both the infrastructure that are hardware, like the waste management facility, but also the infrastructure that are software and the data, the insight, the information that flows across the product lifecycle.
So you've come to us today with a few examples of companies using circularity in innovative ways to try to explain the concept. So what is the first one you have on deck?
The first one is a company called 57th Street Design, and I love them because they're really about rethinking the design and the manufacturing of the products.
So 57th Street Design, and they make furniture.
They built something called design circulation, which is a service that take back, restore, and recirculate the furniture. And they really had to rethink the design itself of this furniture so that they can create a system where they never discard anything in the furniture, but rather they recirculate them from home to home in perpetuity, basically.
How do they make sure that a table that's potentially trashed in one home is being used as another piece of furniture in another home eventually?
They have different design principles. The first one is that they're using solid hardwoods and hand-wrapped finishes to ease the repairability and the durability of this product.
That makes sense. Just make things of high quality and then you don't throw them away.
The second is around standardization. So they are working into having parts of this furniture that can be transferred from one type of furniture to the other. For instance, if your table legs are broken, you can replace them with chair legs or replace part of this table into a bed, for instance. They're also thinking about the ease of disassembly so that they can repair the bespoke part of their furniture. And that's interesting because typically when you think ease of assembly and disassembly of furniture, you think of IKEA, and typically IKEA are kind of a almost single-use furniture, unfortunately, in our society
right.
today.
The opposite of circular. It just goes in one direction. Yeah,
exactly. But here they're taking the same principle associated to ready-to-assemble design, but with the mindset that you can easily disassemble them and therefore repair bespoke parts of this design and this furniture.
So it sounds like the innovation in total with them is like to use the design of the product to aid circularity. Everything is made so it can be disassembled, reused, refurbished. And this is a fundamental part of the design. It's not done after the fact.
Exactly. And I keep on saying you will not recycle something if it hasn't been designed to be recycled. It's already hard to recycle something when it has been designed to be recycled. So if it's not. So this is really, I think, a company that exemplified that idea of like thinking circular at the design phase. Circularity starts with design.
So what's another aspect of circularity where there are some innovative approaches out there that you've seen?
So I've talked to you about the importance of rethinking our infrastructure, both from a hardware and a software almost perspective. And I think there's a company that exemplifies that quite well called AMP Robotics. Mm-hmm. And they make AI-based robots to improve waste sortation at waste management facility. So at a high level, it's basically robots that pick up trash on the sortation line in this facility.
Right. So there's a conveyor belt and the robot senses what's what, pulls out the recycling stuff, or like maybe pushes it with a puff of air and it separates it from the trash.
Exactly. And so these robots are trained in recognizing material type and different types of trash. And to train these robots, Emprobotic needs a lot of data, aka basically pictures of trash to help them recognize. Emprobotic is today so successful at what they're doing that major consumer brands are proactively sending them pictures or design of their new products before they even hit the market, so that the robots can learn these new recycling trash that are coming their way. Like, for example, they are currently working with Caring Dr. Paper that introduced new recyclable K-cup pods for coffee.
This K-cup pod is like the single serving coffee thing that goes into a press.
You probably know, or maybe not, but K-cup pods are non-recyclable. And so, when now they're going into a recycling management facility, they are not sorted out and they go straight to landfills. Now that you have one brand doing recyclable K-cup pod, how do you sort specifically this K-cup pod? And so the example here that they gave me was that they are working directly with the company on ensuring that the robot can recognize the specific K-cup pod and sort them so that they end up in proper recycling streams.
So in essence, what's happening is, to ensure circularity of materials, the companies that make things and make bottles and holders and little single serving packs of ground coffee are feeding that information to Amprobotics so that when they come into the waste stream, they recognize them and know how to recycle them.
Exactly.
Yeah.
And I think today one of the issue that we run into is that designers don't have the right information of what can be recycled or not. And then waste management facility have limited information about what is coming their way, and therefore they can't adapt their infrastructure to actually handle what needs to be recycled. And so what's really interesting with Emprobotic is that they are connecting the dots and basically closing the loop, as we like to say in circularity, with both the data and the insights from flowing from this company to the waste management facility and the hardware that is actually making the sortation process more efficient.
So what's another aspect of circularity that other companies are using to make the world less wasteful?
Yeah, and the last example is a little bit maybe start with similar stories that we've heard about circularity, which is really around how are we handling the amount of waste that we are sitting on right now, and kind of solving also the plastic problem. And so it's a company called the Plastic Road, and they're recycling plastic into prefabricated roads. They are actually modular pieces of road that are containing a drainage system, and they work like a Lego box. So you can just put them in and assemble it into the road, and actually it can also be pulled out pretty easily. It's using recycled content. It also can be recycled multiple times.
Yeah. And so these are modular roads. So it's kind of like it's a pre-made piece of plastic that you can drive over with your bike, or are they made for cars as well?
Yeah, they started with some bike lane, and they have made some strength tests that shows that cars can ride them on as well.
And so therefore you can lay down a road that has better drainage because it's sort of manufactured in this way, and it can be laid down really quickly because the pieces are prefab and joined together, and then it's a road.
Exactly. I mean, it says like it's faster to build because it is prefab and it's just a Lego box. It's much lighter, less carbon emission because it comes from recycled sources and doesn't require any excavation, no heavy foundation, no concrete or asphalt layer.
When you think about the concept of circularity, like what is this project sort of tapping into for you? Like what is it achieving that gives you some kind of hope, or you think is on the right track?
It's kind of this concept that we, big thinker in circularity, love to talk, and it's the idea of city as material banks. And the idea that, when you're going to build something new, you can look into what is already there into your own city, and maybe what is soon to be demolished that you could recycle or reuse. And, this idea of cities as material bank is also the idea of like old building and infrastructure can become material resources for a new building, new infrastructure, and other industry within that city.
Yeah. I think that's what I like the most about these examples is that the heart of this seems to be about sharing information. So if you know that this much plastic is generated by your city over time, or that building is going to come down and all this steel is going to be made available, then you know what you can build. And as long as you have all that information and it's passed through to the right people, you can close the loop on your circularity by really just having this material bank, as you call it, to reach into and then build things without creating more waste. It's kind of stunning, and it's also just like it's my favorite part of design is the part of it that's common sense. You know what I mean? And so the hurdle that it seems like is that the method for obtaining new materials is so streamlined and simple, and the method for getting used materials is more complicated. And it seems like the big hurdle then is to just make both the information and access to recycled materials as easy to get as it is to order something new out of a catalog.
Exactly. I mean, I think your comment on information and data is really spot on. It's like circularity is really going to be unlocked when we have information that flows throughout the entire life cycle and value chain of products, material, and components. And we really need to have data at the center that start connecting stakeholders throughout this life cycle. So I've given the example of connecting designer with waste management facility, but there is also material suppliers with manufacturers and so forth. You can look at it in different angles throughout that cycle. I think there's another thing is also a concept that typically with sort of that single mindset of recycling, and once again the idea that we are recovering material to make always the same product, there is this concept that material then downgrade and therefore lose value. And really to unlock circularity, we need to sort of cross-pollinate these value chains so that maybe the waste from one industry becomes really valuable in another industry, and we stop kind of this vicious circle of this downgrade of value of material throughout the value chain.
Because if you were to endlessly recycle a plastic bottle, eventually the plastic becomes so degraded that it doesn't serve as a plastic bottle anymore. But if you took a somewhat degraded plastic bottle, you could make the perfect road with it. And therefore it doesn't get degraded in the same way. And so it's like the old adage of one man's trash is another man's treasure.
Exactly. But today the information doesn't leave a single industry, and even within an industry there often doesn't even leave a single company. So how do you unlock that information so that the next person building their roads know that there is all this pile of plastic trash in this factory waiting for someone to use it?
99% Invisible's impact design coverage is supported by Autodesk. Autodesk enables the design and creation of innovative solutions to the world's most pressing social and environmental challenges. Learn more about these efforts on Autodesk Redshift. That's autodesk.com/redshift, a site that tells stories about the future of making things across architecture, engineering, infrastructure, construction, and manufacturing. At the beginning of 2021, and what a 2021 it has been so far, 99% Invisible is Katie Mingle, Kurt Kolstad, Delaney Hall, Emmett Fitzgerald, Sean Rial, Joe Rosenberg, Vivian Leigh, Sophia Klatzker, Chris Berube, Abby Madolan, Christopher Johnson, and me, Roman Mars. We are a project of 91.7 KALW in San Francisco and produced on Radio Row in beautiful downtown Oakland, California. We are part of Radiotopia from PRX, a collective of the best, most innovative shows in all of podcasting. Discover, listen, and support them all at radiotopia.fm. You can find the show and join discussions about the show on Facebook. You can tweet at me at Roman Mars and the show at 99pi.org. We're on Instagram and Reddit too. If you like these mini stories, we have one more for you next week, but we have years and years of them going back, and they are always fan favorites, and you can find them all at 99pi.org.
Radiotopia.